Let's talk about mass energy equivalence. Guys, this is where, I have to tell you a little backstory and then come to this particular formula. Okay, now when we talk about mass energy equivalence, now long before this particular formula, we all know this mass can be converted to energy. Very simple example, burning of wood. You have wood, you start, you put some kerosene or you put some oil, you burn it. Now that solid is completely converted into energy. That means whatever that mass we had was converted into energy. Okay. Now we all know that, okay, this is how it was happening. But then nature is very symmetric. In the sense, if something happens, then the reverse is also possible. If something is expanding, then in the other way, it has to contract. It's always the case. Nature loves symmetry. So if mass can be converted into energy, can energy also be created? Can we get the mass back? Is it possible or not? This was a very big question. Okay. Now, for a long period of time, it was taken into consideration that mass can be converted to energy, but energy cannot be converted into mass. Back then, this was the case. But in the early 19th century, you all know Albert Einstein. So, a very famous person. He came up with a particular formula. Now, why this formula is very important, that E is equal to mc square. Why it is so important? Because this gives a relation that mass can be converted to energy, energy can be converted to mass. This was the very first formula in physics which gives us the relation between two things. And it basically proves that nature is still symmetric. Alright. Now, this is the reason why the formula is so famous, E is equal to mc square. Where everywhere you must have at least heard or seen this formula at least. Now, what are the things we have? M is the mass of the body. Okay, c is the speed of light. So, with this, when you convert that mass into energy, we get E is equal to mc square. E is the energy, m is the mass, c is the velocity of light. Okay, see, we know that velocity of light is extremely high. 3 into 10 power 8 meter per second. It's very, very high. Correct? That means, if you convert 1 kg of anything, are you going to get so much of energy? Practically, no. Or, we can say the answer is both yes and no. Okay, the reason yes, theoretically it is possible. Okay, practically it's not possible because if you're talking about 1 kg of anything, maybe 1 kg of water, 1 kg of air, whatever it might be, converting every mass into energy is not possible. Practically not possible. That's why the answer is both yes and no. Okay, theoretically yes, practically not so. Okay, that's why. Now, coming to this formula again, E is equal to mc square. Here we are talking that the body is at rest. Okay. So, what we take E is equal to m naught. M naught is what we call as the rest mass of the particle. Suppose if the body is moving, then the body has kinetic energy also, correct? Say T is the kinetic energy. Then the total energy becomes E is equal to m naught c square plus T. Okay. Or what is the kinetic energy then? Kinetic energy T becomes E minus m naught c square or m minus m naught into c square. Okay. Now, there is another thing called as a mass defect. So, which you guys are going to learn in the next upcoming videos, couple of videos after this. Now, that mass defect is, I'll just give you a glimpse of what it is. See, mass defect is when nuclear reactions occur, couple of, very small amount of mass gets converted to energy. Okay, there is a small mass defect between the reactants and the product. That's what we call as the mass defect. So, delta M is the mass defect. Then whatever that energy conversion we have E is equal to delta M into c square. Okay. So, this one formula E is equal to mc square, it changed the entire perspective in physics. because we can figure out kinetic energy, we can figure out what is the binding energy, which you guys are going to learn later on, what is binding energy and all. Binding energy, it also we can also understand a lot of things about the photoelectric effect using this one. Okay, photoelectric effect, you guys have already learned that, isn't it? So this is why this mass energy equivalence, that is E is equal to mc square, is a very, very important formula. In the next upcoming videos, you guys are going to learn about a couple of units what we use for to measure the nuclear mass, and also a couple of other topics.